Okay, so next part is preparation of haloarene. Preparation of haloarenes. Haloarenes. Firstly, we prepare the haloarenes. Okay, before starting this, one thing you have to remember that haloarenes cannot give the nucleophilic substitution reaction, because as you know that in haloarenes there is a partially double bond character between the halogen and the benzene rings, so we are not able to normally, so it is a stable compound, so it is not possible to break the this bond between the halogen and the benzene ring because of having the double bond character. So that is why it is not possible to give nucleophilic substitution reaction. That is why for haloarenes we use the electrophilic substitution reaction. Okay, so the first reaction is from hydrocarbon from hydrocarbon by electrophilic substitution reaction by electrophilic substitution reaction. Substitution reaction. See, like if we are having a toluene, alternate double bond character, and when we react it with chlorine in the presence of aluminium trichloride, so what will happen here? As you know, in the benzene ring, pi electrons are there. So if these pi electrons are shifted, minus, minus, and minus, because of these pi electron at a time, they will develop a negative charge at ortho and para position. At a time, at any instant, they form a electronegative terminal at ortho and para positions. Alright, see here. Why we use the aluminium chloride? We are having the chlorine. When the chlorine breaks, so one chlorine will break in positive charge, one chlorine will break in a negative charge. Okay, it will form an electrophile. This negative ion chlorine will get attached with the aluminium chloride. Aluminium 1, 2, 3. Cl minus, Cl. Okay, so it will form a AlCl4 minus. So Cl minus will get attached with the aluminium chloride and form aluminium AlCl4 minus, and this electrophile now is free to attack in the benzene ring. So it will attack in ortho or para position. Okay, and it will form a product. When it attached in ortho position, it will form a ortho product Cl, and if it attack in a para position, it will form a para. So this is the electrophilic substitution reaction where electrophile attack in a benzene ring and get attached at ortho or para position. Okay, and forms two products. The second method is by direct halogenation. By direct halogenation of benzene. By direct halogenation of benzene. Here what we do, we directly react the benzene with halogen, that is X2, in the presence of aluminium trichloride. Here in halogen we use bromine and chlorine. And we can't use fluorine and iodine. If we react the benzene with iodine, then it will form some HI and it will give the reverse reaction. So we don't react it with iodine. And if we react it with fluorine, so because fluorine is very explosive, so it will gives explosive reaction. That is why we cannot react it with fluorine. So usually we react with bromine or chlorine with the benzene ring. It will form chlorobenzene or bromobenzene. Chlorobenzene or bromobenzene. This is the direct halogenation of benzene ring. And we will get the product of haloarene. So the next method is by benzene diazonium chloride. By benzene diazonium chloride. Benzene diazonium chloride. In this we also study about the Sandmeyer's reaction. Sandmeyer's reaction. So whenever we react the benzene or aniline with HNO2 from 0 to 5 degrees Celsius temperature, it gives us benzene diazonium chloride, that is N2 plus Cl minus. Now when we react it with CuCl HCl, it will gives us chlorobenzene plus nitrogen gas will release. When we react it with CuBr plus HBr, it gives bromobenzene and nitrogen gas will release. When we react it with CuCN slash HCN, it will give cyanobenzene Cn and nitrogen gas will be released. When we react it with, so these are called the Sandmeyer's reaction. Sandmeyer's reaction. When we react it with Ki, so it will form iodobenzene, nitrogen gas will be released, and when it will react with HBF4, okay, so it will give fluorobenzene plus BF3 and nitrogen gas will release. The last reaction is called Balch-Schiemann reaction. Balch-Schiemann reaction. So these are the reactions of benzene diazonium chloride with different products, and they gives haloarenes.